Okay guys, so what we're going to be looking at today is how do we figure out whether a set of data is linear, quadratic, cubic, or exponential. Those are the four types of graphs we're going to be looking at. Linear, quadratic, cubic, or exponential. It's going to be one of those four. Alright, so first of all, if it is going to be linear, quadratic, or cubic, there will be finite differences. You don't need to write down the definition of finite differences. We already did it earlier. That's where you just see what do you add or subtract to the output to get the next y value. If we don't have any finite differences and we have a common ratio, meaning that we multiply by the same value all the time, that's going to mean that it's exponential when we have the common ratio. Another thing you will want to jot this down though is that point slope formula is y minus y sub 1 equals m times x minus x sub 1. You need to know that if you don't already. You also should know how to find slope. Slope is really the same thing as this. The slope formula is y2 minus y1 over x2 minus x1. Do you see how if I cross-multiplied this function, look at this real quick. If I cross-multiplied this function, I get y2 minus y1 equals m times x minus x1. See how it's the same thing? They're both the same formula. All right, so let's look at number one here. You don't even need to write this down, just watch. So when I look at this, I can see that this is an increase of a half. That's an increase of a quarter. That's an increase of 1, 2. That's an increase of 4. Those are not the same. I'm not adding the same amount on every time. What's happening instead? What are we doing? Not adding, we are doubling every time, aren't we? So this would have to be exponential. With the ratio is going to have to be 2. Now, I can get this function pretty quickly. Y equals AB to the x is the formula that I use for exponentials. A is always the initial amount. What is the initial amount? When x is 0, what is the value? 0.5. So I know the function has to be y equals 0.5. B is always going to be the same thing as the ratio. So what's the ratio? What are we multiplying by all the time? 2. So it's 0.5 times 2 to the x. That would be the equation. It's that easy to come up with an exponential equation when we're given a nice set of data. But the only reason this was easy to do is because they gave me the initial value and I could easily see what the b value is. If I wanted to check this, watch what I could do. I could just plug them in by hand. Like if I plug in 2, 2 squared is 4, half of 4 is 2. Plug in 3, 2 to the third is 8, half of 8 is 4. See how I could do that? I could also put it into my calculator and look at the table of values. So what about the next one? See how the x's are evenly spaced, and they have to be, and they are. What about the y's this time? Is this a common ratio? Am I multiplying by the same thing? What am I doing instead? So subtracting 2, subtracting 2. That's what we call a finite difference that's going to be the same, and it's on the first finite difference. So when we have the first difference is the same, it's x to the first, so it's linear. You might want to jot this down if you don't remember it from earlier, but if you do, you don't have to. If the second differences are the same, then what is it? X squared is quadratic. And what about if the third differences are the same? Cubic. All right. Cube that function. But this one right here, the first differences were the same, so it's linear. If I want to find the linear equation through these points, I can do it pretty easily. I first want to find the slope. So I'm just going to look at any 2 points. Let's use 0, 3, and 2, 1. I'm going to find the slope between those 2 points. y2 minus y1, x2 minus x1. I get negative 2 over 2, which is negative 1. So negative 1 is the slope. The reason it's not negative 2 is because the x's are going up by 2's instead of 1. So there's my slope. Now I can use point slope formula. Y minus y sub 1 equals m, x minus x sub 1. Finishing this, I'm going to have y minus 3 equals negative 1x, and then that's 0. So y equals negative x plus 3. That's going to be the linear function that goes through those points. Questions? All right. And guys, can you see how this would work even from the beginning? Like once I knew the slope, this is the y-intercept. So if I had just noticed, oh, they already gave me the y-intercept, I could have gone directly to that right there. Okay, let's go on to this. Okay, so on the next one, we have to determine the type of function represented by the table. Does it look like we're multiplying by the same amount every time here? No. Let's do the differences. What are they? Tell them to me. 13, 15. Okay, so there's the first differences. They're not the same, are they? So now we're going to go to the second differences. 2, 2, 2, 2. So what does that tell us then? It has to be quadratic. And that's because the second differences were the same. Now, if I want to come up with an equation for this, I probably want to go back to my calculator because there's no real quick way to come up with a quadratic function. So what I'm going to do is I'm going to go to Stat, Edit, and let's just put in 3 of them. We don't need to do all of them. So I'm going to go to L1. I'm going to put in 6, 7, 8. Into L2, I'm going to put in 34, 47, 62. Then I go back to Stat, Calculate, and this is a quadratic regression. And I go down to Calculate. And this is my quadratic regression. This b value is really just 0 because it's 1.5 times 10 to the negative 11, and that's just 0. The calculator just kind of messes that up sometimes. So my quadratic function then is going to be y equals 1x squared 0x minus 2. If I wanted to check it, plug in a value, 7. 7 squared is 49, minus 2, works. 11 squared is 121, minus 2, that works. See how I can kind of check and make sure it's okay? All right, let's look at number 2. These are evenly spaced, that's good, they have to be. We looked at whether we can multiply. Is there something I can multiply by each time to get the next value? What can I multiply 1/5 by to get 3/5? 3. So in this case, yes, our ratio is 3. I cannot come up with an equation on my own because these are not going up by 1. So I don't really know what the b value is. R and b are only the same if this is going up by 1. See how here these were going up by 1, but now it's going up by 2 for the x's. So I can't find out what b is. So I'm going to have to put it into the calculator. Go to Stat, Edit. We'll just put in like the first 3 again. Negative 5. Oops. Negative 5, negative 3, negative 1. And then we'll put in these 1/5, 3/5, 9/5, and then just go ahead and go to second quit, go to stat, calculate. Now which one am I going to choose? What did we just say this was? Exponential. So I have to find exponential. There it is. It's way down there. Exponential regression. Go down here to calculate, and there we go. And I notice this one does not have the diagnostics on. I'm going to turn those on. You guys probably have them on from last time. I just want to turn them on to show you something. Okay, so now, let me go back. Okay, so I'm going to do this again. Do you notice how when we figure this out, how it says r squared is 1? That means it's perfectly exponential. The closer that is to 1, the more accurate the model we come up with is. So this function is y equals 3.118, we'll round to 3 decimal places. That's going to be our a value, times 1.732. That's 3 decimal places for our b value, and then to the x power. That's going to be the exponential function. So on some of these we're going to be using our calculator, on others we're not. The next type are some that we're not. I'm just going to do one of these. We'll see if we need to do another one, we will. They tell us to write an exponential function that passes, or in this form, y equals ab to the x, and it has to pass through these points. Here's what we're going to do, guys. This is x, this is y, this is x, this is y. I'm going to plug these in. I plug in y is 2, a I don't know, b I don't know, x is -1 for that first point. Now I'm going to do the same thing for this one. Y is 32, a we don't know, b we don't know, x is 3. How do I rewrite this so that I don't have a negative exponent? 2 equals, what do I have to do with this b to the -1? Take it to the denominator. So 2 equals a over b. And I want to be able to solve this. So I want to solve this for a, and I want to solve this for a. So what we're always going to do is solve both for a. What do I get if I solve this one for a? A equals what? 2b, right? What does a equal over here? 32 over b cubed. You guys see that? Understand why? So if I have a equals 2b and a equals 32 over b cubed, now I can set those two equal. So I say 2b has to equal 32 over b cubed. How do we solve this? Cross multiply, right? So cross multiply, you're going to get 2b to the 4th equals 32. What do you do now? Divide by 2, you're going to get 16 equals b to the 4th. So to solve this, go to the 4th root. The 4th root is 16. It's really plus or minus 2, but the basis on these exponentials always has to be a positive value. So, positive value. So we have to say b is 2. How do I figure out what a is? Because we're trying to find out what a is and what b is. How do we find a now? Plug it in anywhere. We can plug it in here. A equals 2b. B is 2. So what's a? 4. So here's my equation then. I'll go up here. Y equals a, which is 4, times 2 to the x. That's the equation that's going to go through those 2 points. Of course, it's a lot easier just to put it into your calculator, but I want you to practice this as well. Do you need to see another one, or do you think you understand the process? I'll start one more and just to show you real quick. Okay, how's this going to go? Baxter, how do I substitute this one in? What's it going to be?
So it would be 9 equals a b to the 2.
Right. Okay, and then, Becky, what would I do for this one? Keep going. All right. Now what do we do? Drew, do you know what we do now? No, can't do that. I have to solve each one of them. Yeah, Sydney? Right, so A is going to be 9 over B squared. This one is going to be A equals 324 over B to the 4th. See, I can't take the 4th root because there is no 4th root of A, so I have to do it this way. So now A equals this and A equals that, so I have to say 9 over B squared equals 324 over B to the 4th. Now what, everybody? Cross multiply. So 9B to the 4th equals 324B squared. So I'm going to have 9B to the 4th minus 324B squared equals 0. I'm going to factor out a 9. Is 324 divisible by 9? What is it? 46 or 36? Thank you. So I'm going to factor out a 9B squared, and I'm left with B squared minus 36. Well, this one would make B equal 0. Is B allowed to be 0? No. So this is the one we're going to solve. So B squared equals 36. B's plus or minus 6. Can't have a negative, so B has to be 6. I said I was just going to go a little bit, didn't I? Oh well, couldn't stop. So now we have to figure out what A is. So I can plug in here, or anywhere. What's 9 over 36? 1/4. And so here's our equation. Y equals 1/4 times 6 to the x. That's the function that would contain those two. Okay? Pretty easy, right? So you've got your assignment up there. Have that ready to go for tomorrow.